Hi everyone, welcome to CV parsing using Spacy 3. CV usually also called as resume. We will be using a Spacy 3 to parse our CV, and feature of Spacy is their NER named entity recognition. So we'll be using that particular feature. I'm sure if you are watching this video, you might have watched my previous videos, all videos on Spacy 3. If you have not watched, please do watch those videos. Otherwise, you may not understand this overall, the lecture properly. So what's the resume parsing? This resume parsing is a technology which converts unstructured text data into a formatted structured data. For example, let's say you have a text data and so many informations are written in the text data and you want to structure those into a tabular format. It's difficult if you try to do manually. So there are the algorithms like this CV parsing algorithm where we are going to use our NER methods. You can do this in a tabular format quite easily, like you can extract the name, phone number, degree, university, skills, email, other links like GitHub, LinkedIn, or any other project GitHubs, designations, previous companies, the year of the experience, all those information you can get from the CV parsing algorithms. All right. So along with the Spacy, we will be also using here transformers. So the transformers is the type of new algorithm which uses the deep learning and the attention head. Let me show you quickly here. There is the transformers in NLP. There are many type of the transformers in the NLP. You can see in the images here. The transformers are something like this, where you have encoder and the decoder. The text data is passed through the encoder and then through the through the decoder output is produced there. And internally it uses their deep learning feed forward and multi-headed attention neural networks there. All right. I have taken a detailed lecture on a YouTube about the BERT, which is a type of the transformer. So let me just show you that. It is the first time. All right.
Hello everyone.
So you see there, I have this one here. The pre-training of the deep bidirectional transformers for language understanding. So this particular introduction is given for the transformers. You can watch this video at my channel KGP Talkie. Let me just give the link of that channel. The link of the channel is youtube.com/KGP Talkie, and the link for the video is given here. You can watch this video at my channel. Otherwise, come to channel and search there BERT NLP tutorial, something like this. Right there, the KGP Talkie. So you will be getting these lectures related to my NLP videos at the KGP Talkie. All right. So as I told you earlier that we will be using here NER. So NER is actually the techniques to find out like the organizations, person's name, date. So that means NER named entity recognition. So NER is finding out some type of the entity. Like I told you, the person, organization, event, date, or many other entities. So in CV parsing, as we saw that these are the entity, like the university is entity there, degree is entity, phone, name, skills, email, GitHub, designation, work experience, all those are the entity. So those we can find out using named entity recognition. So this one is just an example to get the named entity recognition. You must watch my previous videos. There I have described the introduction of the NER. All right. So let's go ahead and see how we can do our NER training preparation and the data annotation, which we will be seeing in the next lecture. All right. So for the training purpose, we will be following these steps. We are gonna first download base configuration file. Then we will modify the configuration file using our training steps. Thereafter, we will prepare the training data, and then finally we'll do the training and the final testing. So the data is available at my GitHub account. I'm going to show you first how you can get the base config file. Thereafter, we'll discuss about the data. So you can get that base config file from the spacy.io. They provide this base config file where you select what type of the components you want to use. So I want to use their NER. I want to use here GPU and for accuracy. Alright, so you select these methods. Thereafter it provides here a download option, or you can copy this one. Alright, so this whole whole configuration file is already pre-built once you select these options in runtime at the spacy.io site. Alright, so as I told you that this is the first step. Thereafter we need to modify this config file, and that modification is described here. So we will be running python m spacy init fill config. Alright, so init fill config base path output file and these things. Alright, perfect. So these we will be using to fill out our config file. Thereafter we will do the training of our data, but before that we have to prepare our data. So as I told you that the data is available at my GitHub account. So you need to visit there, the github.com/Lakshmi Merit. That's my GitHub account. Let me just write here. That's the data. And you need to get the data from CV parsing using Spacy 3 repository. So that repo you can get it from HTTPS, and then you need to copy it from there. I'm just gonna give that link here as well. All right, so this one, this repository we will be using to get the data. So inside this we have the data folder. Inside that data folder you need to come to the training, and inside the training I have already placed this file there. All right, so once you download this file from here, you will get base config file. So that base config file I have already placed it here, and thereafter this is the training data. It is stored in the format of the JSON. There you need to click it, and you will be getting this is their JSON data. It is saved for 200 CV. All right, so this is a formatted data where we already have named entity there for our training purpose. So there are 200 CVs data is available there for our training purpose. All right, perfect. Let's go ahead and see what are the annotation tools are available for our training purposes. For our data preparation purpose. So these are the tools available for the data annotation. Personally, I like the Level Studio, but you can also use the Docano as well. These are a free tool which you can use there. For example, you can try a demo of the Docano there. All right, so something like this. It is saying that you can just highlight any particular the set of text data. Then you can select any of these text data. You will be seeing that these are highlighted there. All right, so this one is just the demo. Otherwise they have their the complete process to go through the Docano, how you need to install this. You need to visit at the GitHub, and thereafter they have described this, how you can install Docano at your server. All right, so that's the one tool to do the data annotation. For example, the data annotation is done here in training data.json. All this data annotation is done there, like you see. Let me just show you here somewhere. All right, so do you see there? These are the annotated data. So in the text data, it says that the character, the index 229 to 239, there is the designation. Character number starts with 82 to 124. There is the email address. So based on these, we will be training our algorithm, and thereafter for the prediction, we don't need the annotation, right? So prediction can be done on the raw text data itself. There is the another tool which is the Level Studio. So this Level Studio, I personally like this a lot. This is a very good tool. You can use it for the image, audio, text data, time series, multi-domain. I mean, like the text data and the image data together. So you should try the Level Studio. This is also open source, free available software for your for your labeling purposes. For example, let's say if you have thousands of the CV and the resume and you want to train your model, I think you should use a Label Studio for the data annotation purpose. So after the data annotation, you can download the data, and that will be in the format like we have seen our training data. And once you get your data in this particular format, and then you can apply this algorithm which we are going to see in this lecture directly to classify, to train and the classify, or to train and parse your resume and CVs there. All right. So as usual, you need to select their runtime, and this runtime should be a GPU hardware accelerator. Once that is done, you need to install Spacy transformers and the Spacy there. Alright, so it will take some time to install Spacy transformers and the Spacy. While it is installing, I'm going to stop this video and I'll continue coding in the next video. Alright, so installation of the Spacy transformers and Spacy are done. Let's go ahead and start importing the Spacy and other related Python packages. So I say there this import Spacy, thereafter import Spacy dot you can say that from Spacy dot tokens import docbin. So we'll be using docbin to make our document to get the training, and from tqdm import tqdm. Let's go ahead and just run this, and then you see there the Spacy dot / Spacy dot underscore double underscore and version, so that you can get this Spacy here. So currently we are using here Spacy 3.3 for our lecture purpose. All right, so let's go ahead and see which GPU we have. That you can see with this one, NVIDIA SMI. So it will say what type of the GPU we are currently having at our Google Colab. So we are having here CUDA version 11.2, and GPU is, let me see, yeah, Tesla T4 GPU currently we are having here. All right, perfect. Let's go ahead and get the data. So the data we are gonna get from my repository Lakshmi Merit CV parsing using Spacy 3. You need to select here HTTPS and then copy this particular link, and thereafter you need to write here git clone and paste that link there and just run this. So it is going to copy this repository here, and in this you will be having two folders, data and the NLP model. Inside the data folder we have the training data like base config file which we downloaded earlier, that is there, and the training data, that's the train data.json. So we are going to read those as well. I also need to import here JSON data as well. So I'm going to say that import JSON. All right, so once you have downloaded the data, thereafter we need to prepare our configuration file. But before that, let's go ahead and read the data. So I say there import JSON I already did there. CV data is equal to JSON dot load, and inside that I say open, and I'm going to just pass the path of this data. So I say the copy path, and then I'm going to say that open it in read it into a read mode. Let's go ahead and run this. Okay, it says that is not defined. Yes, let's go ahead and run this. All right, we have got the CV data. Let's go ahead and see the length of the CV data, and we should be getting the length of the CV data there 200. That's mean there are 200 resume which we are gonna do, which we are gonna use for our training purpose. So out of these 200, actually 70% will be used for the training, and 30% data we will be using for our testing and the validation purpose. All right, let's go ahead and prepare our base config file in final configuration file. As I had already told you at a training pipeline models there, in this the link there is already given here. You need to come to this training and the quick start. Let me close other files so that you don't get confused there. All right, so just scroll it down a little, and there you will be getting this particular commands there. You need to copy those commands from there, and then you need to paste that commands here. You need to put here exclamation mark there so that you can run this Python command inside the notebook. Then Python m Spacy, initialize, field config, base config and the final config. So you have to give the path of base config file, which is here. So I'm just gonna get the path of this base config file and then I'm gonna paste it here, and then it becomes the final base path. Do you see content CV parsing using Spacy 3, this one, data, training and base configs. And at the same address I'm gonna store config.cfg. Let's go ahead and run this. Once you run this, the config.cfg will be stored here. All right. Perfect. Now it is saying that now you can add your data and train your pipeline. So by using these commands, we can directly train our model. But before that, we have to prepare our data. Let's go ahead and refresh this listing there. We have got config.cfg file there. Let's go ahead and open this CFG file. By default, CFG file actually gets trained for 2000 iteration, and we don't want to get it trained for 2000 there. All right. Actually, it is 20,000. So we don't want to get it trained for the 20,000. That is huge there. All right. So we should be training it for a lesser number of steps. For example, let's say we want to train it for, let's say, maybe just 5 steps maximum, and these evaluation frequency I'm gonna say there the 2. All right. So we'll be training it just for 5 steps because this is a video for the learning purpose. So you don't want to waste much time on the training. After watching this video, you can put it high numbers there and you can train your model. Since this lecture will take time, so I don't want to put a lot of time for training only. All right. So now finally we need to prepare our data, this CV data, which is in the form of JSON data. If you print it, now we need to prepare our Spacy document to get it trained. For example, let's say if you just scroll it down a little, you might be getting somewhere there how all these trainings are done there. Let me see if they have it somewhere. All right. So do you see there, they have written here a piece of code there. So in the piece of code, do you see there, suppose that there is a document, something like this. So this document should be converted into a doc bin document. All right. So that doc bin will be, we'll be converting by using these code and some additional code for our text data. And then finally, we will store our training and test data with the train.spacy and the test.spacy name there. All right. Perfect. So this is all about in this lecture. In the next one, we will prepare our data for the training. Hi everyone. So let's go ahead and try to understand what is the base config and the config file here. We have successfully created a base config and the config file, but I want to explain you here in this lecture how these files are used in the training. All right. So we created these files from here. In the quick start guide, we selected few of these things. Thereafter, this pre-built file was created from there. So that's the same file here. Thereafter, we ran a set of instruction like this. Then a new file was created, which was the config.cfg. So what happened? Based on our system requirement, a new file was created. This file on given as a base file of this one. All right. So what do you see there? It just says that this is an auto-generated partial config file. All right. And it was a new file was created by running this particular command there. So the first line says that the path. So either you can set the training path from the command line itself. Otherwise, you can set the training path from the from here itself. Spacy training data from here, or you can say the .dev training, .dev evaluation data from here. And if there is any pre-trained vectors are there, you can also set those pre-trained vectors here. So in start, it will take all these things as the null there. Thereafter, it says that which type of system we want to use. We want to use the PyTorch, which will be doing the GPU allocation. We are using the NLP pipeline in our Spacy. So the Spacy have a set of the pipeline. All right, it is something like that. It is actually quite huge pipeline in which we have a parser, tokenization, and the NER. See, if we talk about the training pipeline, like what we are going to do in this lecture series, we will be doing NER training there. So there is the text data and the corresponding labels in named entity recognition, and then the loss function or a gradient descent type of the loss function. Then there is the model. So the training of the model is happening, then in runtime it is doing the prediction, and then it is doing the data evaluation, and then finally it is again evaluating the model, and it continues till the number of iteration it reaches, which you have defined in baseconfig.cfg. I'll tell you that. The language we are using here, the English language, and in the pipeline we are using the transformer and the named entity recognition. All right, so for the transformer, I have already shown you. There is a lecture I have taken on my there is a lecture I have taken on my YouTube channel that you can come and read it here. So you can say the BERT NLP tutorial. You can search it here like BERT NLP tutorial KGP Talkie. That's my YouTube channel name. Thereafter, you will be getting these lectures. So where I have discussed about the transformers. So you will know about the transformers there. Then there are the components for each of these transformers, like what type of the tokenization and what type of the transformers we are going to use. In this lecture, I have described about the BERT transformers, but there is also another transformer which is known as the Robert based transformer. So these type of the transformers are available at the Hugging Face site. So there you will get also so many other type of the transformers which you can use. You can click on the models. You will be getting all the set of the transformers which can be used in your algorithm. All right. Thereafter, it says that there is the transformers and some internal parameters for the transformers. All those are set here. Like in the transformers, what is architecture which you are going to use, like how many hidden layers are going to be there, and you know, the gradient factors are there, and like you know, the evaluation data set, and in the training it says that how these gradients and the optimizer is there. So it is using there the Adam optimizer, and this one says that how many the steps are going to be there in the optimizer. And other than that, you will be seeing here in the config file, once this file is modified, you will be seeing there inside the training component, you will be seeing there how many number of steps you want to train your model. So there this max step says that total 20,000 steps you should train your model. Evaluation frequency is the 200. That's mean it will be evaluating the model at every 200 iteration there. And the dropout factor is being used there, the 0.1. So you can test your model by changing all of you know, some of these parameters just to tune your model so that it can perform better on your particular type of the data set. Other than that, you don't need to understand the much deep this config file. It's okay if you just get started with the config file by default. Moreover, you only need to change the number of steps. Other than that, I think you may need to change the transformer type which you want to try out. Like here by default, the transformer type is Roberta used. It was somewhere I had saw that. Yeah, so it's the Roberta base. You can use other Hugging Face models as well from here to try out if that performs better than this particular model here. Alright, so this is all about in this lecture. In next lecture we will continue our coding. Alright, let's go ahead and prepare our Spacy document there. So I say def, that's the define, get Spacy underscore doc, and in that I'm going to pass there a file where we will be writing our data if there is any error. Alright, so for the doc bin you need to get a blank Spacy model there. So you need to write there Spacy dot blank, the English language model I'm going to use there. If you are working with the English language, then of course you have to use the English model there. Then get a blank doc bin object there. Thereafter we need to iterate over the data which we want to convert into .spacy format. So for text and a note is the data point. If you see this data correctly, so similarly our data is also made there. So there is a text data and then the annotation data. So this type of the data I had also shown you in my GitHub as well. Let me show you that once more. So in this GitHub account there is the JSON data. I think that JSON data I can open here directly. So in that JSON data you will be also having the similar type of the data. So that's the text and the annotation is there. So like this, do you see there? So one is the text data, thereafter the annotations are made something like that. So you need to write here for text a note in data. So actually I need to use here the TQDM so that I can see the progress, how much. So TQDM is used to see the progress, how much data is actually encoded in the runtime. Let's go ahead and make a document here. So the doc is equal to the nlp.make underscore doc, and in that I'm passing the text data. So a doc object is made for the text data. Now we need to parse our annotation data. All right. So our annotation data is actually written as the entities inside our JSON data. All right. So inside our JSON data, let me show you here. I think I need to open it once more there. Then I'll be showing you. So our entities are one text data and then there is the entity there. For example, I think I have that CV data and then let's say this 0. All right. Even though if I print it there, I don't need this one. So there you see the first one is the text data. Thereafter there is the entities. So this one I want here. All right. So in annotation, I want that entities there. So I write there here a note is equal to a note and then entities there like this. All right. So I got this entities there. So whole annotation data now I got there. Once you get that, then let's go ahead and make these entities. So how many entities are there? In advance, we don't know all the entities. Entities are like skills, organization, university, passing years, degree, graduations, all those are the entity labels. And the entity indices are those, earlier I told you the character index there. So those are the entity indices there. All right. So these are the entity indices are there. All right. Let's go ahead and start this. For start and label in a note, I say there the entities. All right. Then I say here skip underscore entity is equal to false. For IDX in range, let me tell you once again. So what happens, each of these entities here, which you see the ENROLL entities, these ENROLL entities have a 3 labels there. Let me just show you again here. So these ENROLL entities, okay, since like it is not present, no issue. So these note entities have these three labels there. These are the start character index, end character index, and the label or entity name there. So that's what we are doing here. Thereafter, I'm saying the skip entity as a false first time, because we need to, we don't know whether this data is correct or not. The reason is actually these data are prepared manually. So the many times what happens while doing the manual annotation, sometimes these data gets actually annotated wrongly. So to remove those, I'm just putting there the skip entity is false. So the for IDX in range start to end. So what actually I want to do here, my purpose of doing this is, let's say if you have one entity like this, so there should not be any entity which ends or start in between these numbers, because the character index from 574 to 580 is already predefined to companies worked at. So this particular index should not overlap with other indexes. Since in this data there is the overlap, that's why I am writing here code to skip those entities which have a overlap. So I say here if IDX in entity indices there, do you see there the entity indices? So if IDX in entity indices, that's mean the entity indices which are already done, then we should be doing here skip there. So I say there the skip entity is equal to true there. And since there is a single overlap, so I'm just gonna break this particular the for loop there. All right. So if skip entity equal to true, then I'm just gonna continue. That's mean I don't want to run it further. So overall that mean to say that that particular entity will be actually ignored. All right, perfect. Now if all these tests are passed, that's mean the entity are not overlapping, then we need to put that entity index in the entity indices there. So I need to just make sure that the previous entity indices are also getting added to this list. Then I say here the list and the range, and in that I say the start to end there. All right. Now this entity indices will be updated so that the next time we can check whether a particular entity is already added in the index or not. All right, perfect. So once this is done, now we need to get the character span. That's mean we have start and the end indices of the character. Now we need to get the whole label or the span from the document, which we will be doing in the next lecture. All right, let's go ahead and now read our character span based on the start and end of the entity model. So I say here try. All right, so one thing actually here I'm maybe missing here. Start and end is okay, that's not the problem. Okay, so because this try should be inside this, so that's what I was trying to understand where this should be. So the try and except I need to use here. So I say there try. Inside this I'm gonna say here span is equal to doc dot car underscore span, the character span there, start and end label is label there. So it is span is equal to the doc dot character span, start and the end label is the label equal to label, and then I say there alignment mode is equal to strict there. So this is the type of the mode is used there. Either you can say there strict or contract there. So these mode can be used there. All right. Then if there is issue, then you can simply do here a continue. Alright, so basically what is happening, it is trying to get the document, it is trying to get the piece of the document which is defined here. Alright, from this to this, if it is there in the document, it is going to get the span, otherwise it will just ignore and continue the algorithm. So I say there, if span is none, that's mean one thing, if there is the error, it will continue, even though if there is the no error and the span is none, that's mean start and the end is the same value, then we are gonna put here the error data. So the error data is equal to str, I'm gonna put there start index and the end index, then I'm gonna put there in string format, and then I'm gonna just use here plus so that I can add it with the text data. So the str text there, and then add it with the new line here. As I told you earlier, I'm passing this file there, the text file. So the file object, by using this file object, I'm gonna write this error data into my file so that the later I can see what are the resume files which are throwing or showing these error there. Alright, if a span is not none and there is the no error, then we need to add this into the entities there. So the entities dot append there a span. So we have appended there a span inside the entities there. Alright, perfect. So once all of these are done, thereafter we need to add, since in the document we have already added their text data, now we need to add the entities inside the document. So that we need to do outside of this for loop. Alright, that's mean we need to do here that one. So that I do like the try, and then the doc dot ents equal to the ents, this one, right? So earlier this was a empty list, but now I'm gonna add it into a doc ent. Once that is done, thereafter I need to add the whole document inside the, now I need to add this whole document inside the db there. All right, so I need to add there inside the doc bin. So the db dot add, then this document there. If there is any error while adding this, then I'm gonna just simply pass it. Once everything is done there, then we need to do here a return. All right, so I say the return db, that's mean return this doc bin object. So now let me just go through once with all these process how this whole thing is happening here. So I passed here a file object in which I'll be writing error data, and this is the actual data, and that data we have seen here. So this data have a two index list. One is the text data and thereafter the entities. So these entities are labeled manually by using a label studio or Docano or any other similar kind of the softwares. And these are the character index. So this character index says that at this particular index to this particular index, this person's company worked at is defined, and here and here. So skill starts with from this index to this index, and similarly all other labels are defined there. All right, so that's what is in the data. Thereafter I make a blank Spacy object and the doc bin object. Thereafter the text data is added, is actually converted into a doc object, and then a note entities got actually assigned to the ENROLL, and thereafter we are actually, since ENROLL entities we have already got, so I should not use these ENROLL entities, I should directly use there the ENROLL there. All right, so this ENROLL there, and inside that ENROLL we are having start, end, and then the label there. So 0 to 12 is the name. Now you see there 0 to 12 will be used for the name there. Alright, so thereafter I check if there is no overlap. If there is overlap, it will simply skip that particular annotation or entity. If there is no overlap, then it is going to add that start to end range into the entity indices, so that next time we can check there shouldn't be overlap for others. Thereafter we have here the span document. So there we have alignment mode as the contract span. Character span starts with the start index and the end index, and the label is also used there. Alright, if span is none, we are going to write that span into our error file so that we can know which span is producing the error. And then finally we are making here a doc entity object, and then we are adding that doc into the doc bin object. So that's all in this lecture, where we prepared our get Spacy doc method. In the next lecture, I'll be showing you how you can divide your data into training and test set, and how you can get the training data. Alright, so we have read our JSON data, CV data in a CV data variable. Thereafter, you need to make one more little change. Earlier I told you that alignment mode should be a contract, but this mode should be a strict mode. Let's go ahead and run this once again. Alright, now we need to split our data set into a two-part, training data and the test data. So for that, I'm going to import here from sklearn dot model selection, import train test split, and in that I say here I have a train data and the test data is equal to train test split, and inside that I have here a CV data and the test size equal to 0.3. That means I'm going to take a 30% data as the test data set and the 70% data as the training data set. Let's go ahead and run this. So we have successfully got the train data and the test data. You can check the length of this. So the train data length is 140 and test data length is 60. That's mean 140 resume we are going to use for our training and 60 resume for our testing, or you can say the validation purpose. Alright, so this code has been already written like the get Spacy doc. Now we need to get the document for our training data and the test data. And you remember there we passed there one more file object. So for this file object we are writing the error code. Alright, or you can say the error lines will be written in that file. For that we need to pass the file object for our error file. Let's go ahead and open error file object here. I say there a file equal to open, and then I say there error.txt file. Error.txt file. I'm opening this file into a write mode. Now I got here a file object. Then I'm saying here db, that's the doc bin object, is equal to get underscore Spacy underscore doc. I'm calling this function our function. In that I'll be passing a file data and the data object there. Alright, perfect. So first I get the train doc bin object. I pass here a file and the train data. Thereafter, sorry, this should be the train. Thereafter I need to store this db into the disk. So I say there db to disk, and the training data which I'm going to store, I say the train underscore data dot Spacy. And similarly I need to get the test data as well. So there I say the test, and then here I say there test data dot Spacy. Once all these things are done, thereafter I need to close the file object of the error file object. Alright, so this is going to this is going to make here a Spacy doc object for the training data and the test data. You will be seeing here error.txt file. So this error.txt file, you see, this will be saying us that what are the entities which are producing the error. So these are the total number of the entities which had produced the error there in our whole data set. You see, these are not all CVs, but in fact each of these CVs have a few of these CVs have like 5-6 mistakes are the errors. So those mistakes and the errors are highlighted here. Some of these CVs might be having like maybe overlapping entity or something like that. So that's why this error, error entity was stored into error.txt file. Not to worry about that, because you can see this like the db.token to understand there how many the files are there. Is it like that, or all right, it's not db.token. It was something like that. I'm not remembering. Anyway, so we have, let me see if we have it here somewhere. Do we have? Yeah, it's a tokens. So the db.token says that how much data we have into our test data. So this says that these are the data stored into db.tokens. Maybe you can get the shape of this data. So there you will know the total shape of this data. Okay, so shape is not available in the list object. So of course I need to get here the length of these tokens. So you will be getting there the 60, because we are training we are testing our algorithm on the 60 data points. That's mean on the 60 CVs, and 140 CVs are being used for the training purpose. Once you got your .spacy data set, thereafter we need to train. Do remember we started from the quick start, and then we created there our config file, and just below that it is written we can use this particular commands to train our model. So I'm just gonna use that command here to train our model. You need to put here exclamation mark python mspacy train config.cfg. We need to give the path of the configuration file. So do you remember the configuration file path is this one where we had written this? I'm just gonna take this config file from there, and then I'm gonna put that config file here. All right, thereafter we need to provide the train.spacy path. So we have that train.spacy is there, the train data.spacy and the test data.spacy. So those particular names we need to use here. So I say there the train underscore data.spacy, and then here I say test underscore data.spacy there. All right, perfect. Let's go ahead and run this. All right, so now our model training will start, but somehow it is saying that it could not initialize model from config. No training seed found. All right, so seems like a few things we are missing here. Maybe we need to also provide here the GPU, which GPU we want to use. So I'm going to say that I want to use here GPU ID 0. That's mean the first available GPU will be used for the training purpose. All right, still it is saying that there is some issue. Let me see what is the problem. Okay, so the problem is here we provided the base config file path, but actually we wanted to provide the path of this config file, because this config file was created from this base file. So that's the problem. We need to provide here, we need to write the name config.cfg. Thereafter you need to run it. So your training will start and the model will be saved into .output format. So there would be two type of the model, and there you will be getting here model based and the last model. I mean the model last. So the model best, because it will be trained on the multiple iteration. Every time it stores the best performing model in the model best, and the current, you can say the last model will be stored into a last model or model last there. All right, so it will take some time. Now you see there it has initialized the components, transformer and the NER. It will definitely take some time to complete the training, and once the training is completed, we will see in the next lecture how you can do the model testing. All right, so our model have been training since last 60 minutes, and seems like I need to stop this model, otherwise it will still take like 1 more hour. And one more thing I wanted to tell you, I had changed my my CFG file, this file, before putting it into a training, that you need to make sure you train it for at least 1000 out of the 2000 total 2000 iteration. So currently I'm training it for the 2000 iteration. 1000 iteration is done, and at every 200 iteration it will do the evaluation of the data. All right, so you can select like 1000 if you don't have much of the time. So the 1000 will take like 1 hour on a Google Colab. All right, so as of now I'm just gonna stop this, and while it was a training, it had created 2 files in the output folder. One was the model based, another one was the model last. So we'll be reading the model based into NLP object, and then we will be doing the NER prediction on that. And do remember one thing here, the current score is just the 33 to 34%. That's mean it's not 100% accurate, but you can put it in the training like 10,000 or even more than that steps. So the accuracy will definitely get improved. Since we don't have much of the time in this lecture, that's why I'm just putting it like a 33% score. That's not the issue. You can put it in the training for a longer period of the time while you are working offline. All right, let's go ahead and just stop it. It will not matter if you stop it. It's not gonna destroy your output. Moreover, it will just stop the training, and whatever the model was stored there in the model based, that will be there. All right, now I need to do the model test. So here I'm gonna say here model test. Let's go ahead and read the model object into an NLP variable. So I say there Spacy dot load, and inside that I'm gonna write model path there, which model I'm gonna load, that is the model based. So for this model based, I'm just gonna use that model here. All right, once you have that, thereafter I'm going to get here the doc object for the NLP. So the doc object for the text data, which I'm using to which I'm just going to take for the example. So I say here my name is Lakshmikant Tiwari. I worked at Microsoft. I have 10 years of experience. All right, suppose that this is my text data, and on this text data I want to find out the NER for which we trained our model. So you can say like for ENT in doc.ent, then you can do the simple print here ent.text data. Thereafter let's go ahead and give some space here, and then you can do like the ent.label. That's when I'm gonna print the entity label here. Do remember our model is just 33% giving the score here. We trained it just for the 1000 iteration. You can train it like 20,000 or even more than that for a better accuracy. Even after that, this model was able to get my name Lakshmikant, although this has missed this Tiwari, and it also got in which company previously I worked, and thereafter it also got how many years of the experience I have total. All right, so that's how you can do the CV parsing by using the NLP. So we used here just a small sample text data. Let's go ahead and use a larger set of the data, and that larger set of the data is available inside the test folder. So inside the test folder I have here a CV written into a PDF format. So I'm going to write a code which will read this PDF format, and this PDF will get converted into a doc object, and in that doc object we will be applying our NLP NLP entity model prediction. So that PDF is downloaded in Google Colab when you downloaded CV parsing using Spacy 3 dataset. That is inside the test data. It is here. We need to just get the path of this CV there. Thereafter, we need to use here a PDF parser. So I say pip install py-mu PDF. So this is a PDF parser. You can say this is a PDF reader which will read the PDF from your local system, and then it will return a text data from the PDF document. All right, let's go ahead and import here a sys, and I also need to import here fitg. All right, so that's the fitg there. Thereafter I say here file name, for which I'm going to write the code to import the text data, this one. Thereafter it's very much simple. You can simply write here fitg dot open file name. Thereafter we need to read this file line by line. All right, so basically what is happening here, you see this file is actually here the object there. So this is kind of the list there which we need to iterate this object. So that we can say like for page in doc. All right, and then I'm going to just say that the doc is equal to page. So this is a list comprehension. It is reading each document, each page from the document, and then there the page is getting loaded there. So now the document will be a list here. Once you get the document as the list, thereafter we need to actually get the text data as well. Actually, I think I need to write here get text. Thereafter I'll be getting the text data from each. I should be getting here. Let me see what is the problem. Okay, I think I need to run this one because I had read this doc without using get text earlier in the previous cell. Now you need to do this. Still it is a problem there. I need to see. Let me try it into another way. Like let's say I say the for page in doc. Thereafter I say like the text data is equal to the text data, and then plus str page dot get text here, and for that I say here the text data is equal to an empty list here. All right, let's go ahead and run this and then see. Although if that throws an error, this should be also throwing an error. This says that it has no attribute. That's mean we need to come back here at the py-mu PDF, and then you need to open this particular library, and then you need to come here. Thereafter we need to see its tutorial, how they are using it to read the document. So there it says that that's the document object, and then how you can access the metadata. All right, perfect. All right, seems like the method has been changed, so I need to use here the load page to read the data. So let's go ahead and use that one. I say here load underscore page. All right, do you see this one there? If you click on this one, you will be redirected to its API. This will be used to read the document. All right, perfect. Let's go ahead and run this. All right, it still says that it has no attribute like the load page. All right, seems like method is changed when I used it the last time. So maybe it is something like this. I'm not sure. I need to check it here. Oh, congratulations. So seems like it is like that. Let's go ahead and see here the text. If we are getting this text correctly. Yeah, perfect. Excellent. So there is additional space here. So that space, I need to get rid of that space. For that, I see text dot strip. And once you get rid of that space, then we need to join these whole text data, which we did here. But still there are new lines there. Do you see so many new lines are there? These new lines we need to remove first of all. So what I'm going to do here, I'm going to split it on these new lines. All right, so it's gonna use those new lines as a split. Thereafter, I'm gonna just join it with a space. So I say it something like this, and then I store it into a new text data. Now this text data is quite quite clear. Let's go ahead and see how this text data is there. All right, this is now quite clean text data. Now, do you remember earlier we used to do the testing? So the same thing, we can copy it from there and we can put it here. And in this NLP, instead of writing this raw small text data, I can simply write here the text there. So the doc is equal to the NLP text. For ENT in doc.ent is print ent.text and something like this. Let's go ahead and run this and then see if it is able to do the parsing of the data. So it says that the Alice Clark is the name, AI machine learning is the degree, Delhi is location. Although this is saying that all these are the degree, but I don't agree with that. Okay, so this girl has worked as the software engineer, which is the designation, and previous companies, this girl has worked on the Microsoft, and the college name is the Indian Institute of the Technology. It is the IIT Mumbai. All right, and seems like all these steps are the skill for this particular CV. So now let me summarize this once again here. If you remember, we stopped our model in the midway. The score was just 33%. Even after that, we are able to get the result. It is not bad. All right, it's almost quite accurate. If you train it for a larger set of document and for large number of the iteration, you would be definitely able to get a better accuracy by using the transformers. All right, congratulations, you have successfully built here a CV parsing using a Spacy 3, and in the Spacy we used here a transformers. Thanks for watching. I'll see you next one.